Hi, this is question 89 on stoichiometry. The percentage yield for the production of ammonia is 70%. Calculate the mass of ammonia obtained when 35 grams of nitrogen reacts with 5 grams of hydrogen gas. So you see it's getting tougher, right? This is 89. So they've given us the percentage yield for the production. It's not 100% efficient, it's just 70%. Yeah, that's still an A though in some places. Right, so 70% of ammonia was produced. That is the percentage yield. And now they're asking us to calculate the mass of ammonia that is produced when 35 grams of nitrogen reacts with hydrogen gas. Okay, 5 grams. So now this is what we're going to do. First off, we are going to figure out what the theoretical yield is, and then we'll figure out what the actual yield will be. If you look at it, what we have here is a percentage yield, that's 70%, and we want to know the mass of ammonia produced. Not the mass of ammonia that should be produced, but the mass of ammonia that was produced. So that means we're calculating the actual yield, knowing fully well that it was 70% that was produced. Okay, so theoretical yield can be gotten from calculation. So first off, we'll write an equation of reaction between nitrogen and hydrogen to form ammonia, and we will balance it, right? So 2 here and 3 here, right? Now, 35 grams of nitrogen, that's what they said, 35 grams, is trying to react with 5 grams of hydrogen. Can we get this in moles? Divided by the molar mass, which is 2 times 14 here, and you're dividing this one by the molar mass of hydrogen, which is going to be 2 times 1. So why did I write 2 times 14? N2, 2 times whatever nitrogen is, 14. So that's it. So same thing with the hydrogen there. So let's calculate what that will be, right? 1.25 for this one, and then this one is 2.5. So these are the values in moles. Now, we need to figure out what the limiting reagent is, because it is that limiting reagent that we'll definitely use to figure out the amount of ammonia that should be formed, which would be our theoretical yield. So how do we do that? We divide these moles here by the number in front, which is 1, and divide these moles here by the number in front, which is 3. Okay, so when you do 2.5 divided by 3, 2.5 divided by 3, that's about 0.83, right? And then 1.25 divided by 1 is about 1.25 still. So it's very clear that 0.83 is smaller, meaning that hydrogen is our limiting reagent. So we must compare hydrogen with our ammonia for correct calculation. Now, 3 moles of hydrogen produces 2 moles of ammonia, but we're given 2.5 moles of hydrogen here. So 2.5 moles will just produce X, and X will be 2.5 multiplied by the 1 across divided by the 1 at the back. When you do all that, you should have 1.667. This is the number of moles of ammonia that is formed. All right, that's the number of moles of ammonia that should be formed, like theoretically. Okay, let's take it to grams, right? So that's the next thing. The molar mass of ammonia is equal to 17 grams per mole. How did I get that? NH3, N is 14, and then this is 3 times 1 for hydrogen. So that gives us 17. So molar mass is 17. Now the mass of ammonia formed, which is our main theoretical yield, right? This is also the theoretical yield in terms of moles, but if you want to take it to mass, then that's it. So the mass would be number of moles multiplied by molar mass, and that would be the number of moles, which is 1.667 multiplied by 17. So what would that give us? 28.3 in grams. So that is the theoretical yield. Okay, so we have the theoretical yield here. We have the percentage yield. We can therefore calculate the mass of ammonia obtained, which is the actual yield. So our percentage yield is 70%. But we know that percentage yield is actual yield over theoretical yield. Times 100%. So that means the percentage yield we're given, which is 70%, I can write that this way. 70% is the actual yield divided by the theoretical yield, which is 28.3. Is this stuff difficult? Is it difficult? So when you do your calculations, they cross multiply and then divide both sides by 100, your actual yield will be 19.83 grams of ammonia. So you notice that this particular question, as well as the previous questions we've been working on that has to do with actual yield and theoretical yield, the actual yield is usually smaller than the theoretical yield. See that? Smaller than the theoretical yield. So that means it makes sense. All right, so this is the answer to the question. 19.83, that's the actual yield, and that is basically all. So let me know how you found this question. Was it easy? Is this one easy? I don't think this one is easy. I feel that there are a lot of places where people can make mistakes, especially if you didn't use the hydrogen to compare with this one. Yeah. I'll see you on question 90. I'll see you on question 90. So please share this particular video, 89, with your friends. Share it with your friends. Okay? That's all. Just share it with your friends. Alright. See you on 90.